For those who are at a distance watching right now, you can see that the derivative will be letter E. Problem number 2 says an equation for a line tangent to the graph at point 0, 1. An equation for a line tangent means, so the D, a D, it rhymes with derivative. Derivative. The derivative of x plus cosine is 1 minus sine of x. So that's going to tell me my slope. So let's plug in 0. Anybody know what the sine of 0 is? Good, it's 0. And so 1 minus 0 is 1. So that's your slope. So which equation up here has a slope of 1 and a y-intercept of 1? That would be letter B. Let's go to problem number 3. F of x is tangent of x, and what is f prime of pi over 6? This requires a little knowledge of your trigonometry. So we're going to use the chain rule again. We have the tangent of u, and we have 2x. The derivative of tangent is secant squared of u, and the derivative of 2x is 2. So I have 2 secant squared of 2x. So this is the same as 2 over cosine squared of 2x. So let's go ahead and plug in that pi over 6. What's 2 times pi over 6? Pi over 3. Pi over 3 is how many degrees? 60 degrees. What is this coordinate at 60 degrees? 1/2 and root of 3 over 2. Very good. Is cosine the x value or is it the y value? It is the x value. So in other words, the cosine of pi over 3 is 1/2. Square 1/2. 1/4. 2 divided by 1/4? 8. So again, all that, you've definitely seen it before within one problem. Seems rather challenging. That's kind of what they do. Number 4 looks like a really tough problem. It's really actually straightforward. So I didn't write this as one of the easier ones, but after this, it's really not too bad. You're going to want to have your graphic calculator ready to go so you can see what I'm talking about. It says let this be the function here and let g be the function given by that. At what value of x do the graphs of f and g have parallel tangent lines? Well, tangent lines are the derivatives, right? This is like, let's say you have, that's one graph and that's another graph. So when is it that their lines are parallel that are tangent? So we find tangent lines by taking the derivative. What's the derivative of 6x cubed? Yeah, I get 18x squared. And what's the derivative of 3e to the 2x? Can we see the derivative of 3e to the 2x? 6e to the 2x. That's f prime of x. So we're simply wondering, when are these things the same? When are they the same? If you go to your calculator and simply turn it on, and this option is going to be used for you multiple times, I type in 6e, and I raise it to the 2x. And then for this g right here, I get 18x squared. And when I zoom standard, I zoom 6. It's going to take a little while to produce the graphs. You see the first one there, and next one drops down. And if I zoom as a box so I can see that intersection better, you can see that these two graphs that they do cross. If I can find that point of intersection, that will be the spot where their tangent lines are in fact parallel. Let's see if we can see that intersection. There it is. How do I find intersection on my calculator? So I can calculate. 5. Press enter on one, enter on the other, enter for guess, and you come up with that 0.391, negative 0.391. So, not too bad when you see the problem worked out. Good. Let's go to one. So this is one that we want everybody to get. And when I say this is one we want everybody to get, that's a cheap way of me telling you that this is a problem I would expect if it was on your test before you took the AP exam. I expect that everybody gets this right. Okay? So this would be a chief type of problem that I would definitely put on your practice test. Let's look at it. Everybody's capable of understanding it. The graph of f is shown. Which of the following could be the derivative? We did a matching game like this, didn't we? So we want f prime. So this is f right here. And what I noticed is that the derivative is positive, 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 positive. Then it's 0. Then it's negative, 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 negative. So I'm looking for something that's above the x-axis, then on the x-axis, then below the x-axis. Above, on below A.
So what does it mean? Oh, but I did decide that it's below, above, not going from left.
Yeah, you maybe looked at F prime.
Yeah.
You maybe said, okay, so it's below, so it's decreasing, and then it's increasing, then it's decreasing. This is F. This is the actual function F. Let's flip it over. This was another great question. It's a little bit more complicated, but it's really not too bad. It says this is a twice differentiable function, which means you could take the derivative twice. Let's make sense out of this. This is a problem that you could definitely get as well. We want to compare these. We want to compare f of 1, we want to compare f prime of 1, and we want to compare f double prime of 1. And I'm going to show you how to make this super easy. Somebody tell me, what is f of 1? 0. Excellent. F prime of 1, that means the derivative, right? Is the derivative positive or negative at 1? Are you on your way up or are you on your way down? We're on our way up, right? It's positive. F prime of 1 is positive. F prime tells us whether you're increasing or decreasing. F double prime tells us concavity. Or in other words, if I were to draw these tangent lines, are these tangent lines, is the slope getting bigger or is it getting less? It's becoming less, right? That means the second derivative is negative. Or in other words, it's concave down. And so therefore, we know that that is negative. So as we put them in an increasing order, you can tell it's F double prime is smallest, then F of 1, then F prime. The derivative shows whether it's increasing or decreasing. We check out problem 7, okay? Which graph am I given? The original, the first derivative, or the second derivative? Second derivative. It asks me about inflection points. True or false? The second derivative tells me about inflection. True, it does. Second derivative has, so it has inflection when the second derivative changes sign. So let's think about where this thing changes sign. X, that would be 0. That would be negative 1. And that would be 2. Does everybody agree that this is a 4th degree polynomial? If you were to graph it, it would look like this. That's the graph of the second derivative. I just generated the graph of the second derivative. That was straight out of your pre-calculus unit from 2 years ago or last year. When does it change sign? Does it change sign at 2? No. Does it change sign at 0? How about 1? Negative 1. So negative 1 and 0 are where the second derivative changed sign. Negative 1 and 0. Increasing. What tells me increasing? Original function, first derivative, or second derivative? Which one tells me increasing? First derivative. I'm going to find the first derivative. F prime of x is equal to 4x cubed plus 2x. And that's what I have. I'm going to graph this. If I take out a 2x, I get 2x squared plus 1. Would everybody agree that there's no solution there? That would be imaginary? Would everybody agree that the solution there is 0? So the graph is going to look something like that. You tell me, this is f prime. This is f prime. So when is f prime positive? Over what interval? 0 to infinity. So that means that that is where this function is increasing. If you were to solve 2x squared plus 1 is equal to 0, you get 2x squared is equal to negative 1, and then you go from there. We don't have time to go over problem number 9, but the answer is D21. And finally, in this situation, it says the graphs of the derivatives are shown above. Which of the functions f, g, or h is a relative maximum? This is one you want to get. Relative maximum happens when the function changes from positive to negative. So these are all derivatives. Does H ever change from positive to negative? No. Does this ever change from positive to negative? No, it changes negative to positive. Does this change from positive to negative? Yes, so this is the only one that has a relative maximum. Score it up.